Hey guys, it's me again, Captain Corey, here to teach you some 6th grade science. Last time we were together, we talked about weather maps. This week we will be reviewing everything that we have learned for these last 9 weeks. Since today is Engage and Explore, we will be filling out our Notice and Wonder sheet. I'm going to show you how to access the science journal. All right, so the first thing you need to do is come over to the RPS page, which is rvaschools.net, as you can see at the top. Then you're going to scroll down to important COVID-19 links, and then you are going to click on the RPS at Home Virtual Learning Platform. Once you get to this page, you're going to click Middle School, and then you're going to click 6th grade. You're going to scroll all the way down to the very last week. You're going to click on June 8th. For demonstration purposes, I'm going to click on June 1st. Once you get to this page, you're going to scroll all the way down, and you're going to click Student Journal link right here. Right? Once you click on this link, it will take you here, right? And this is the last science journal that we have. What you're going to do is to make it your own, you're going to come up here to File. And once you click File, you're going to click Make a Copy. Click Make a Copy, change this to your name, Science Journal Week 10, however you want to organize it, and press OK. If you don't want to do it that way, you can do Download. You can do Microsoft Word. You can do any of these if you would like, but the two that I would recommend would be Microsoft Word and a PDF, okay? Now, looking at this week's looks a little different. You scroll down, we still have our Notice and Wonder sheet, but this week is all about choices, right? So you've learned the last 2 units here on RPS at Home. So now you're going to be able to pick how you want to demonstrate your full knowledge of the topics. So you have a at-home lab choice board, right? You have the choice to do 1 or 2 or 3. You could do all 3 of them if you want to. You have one on properties of water. It's really simple. It's the surface tension and making a barometer. And then for weather, and then for severe weather, there's a baking soda volcano. All right. Down here, we have properties of water, tic-tac-toe. So you can pick 3 or more. And we'll go through this after we go through the videos. And then you have a weather tic-tac-toe, which you can pick 3 or more to do. All righty. So we're going to start off with our review videos for this week. So you can write 3 things you see, 3 things you think, and 3 things you wonder. We're going to watch 3 different videos. Here's our first video.
So we have a riddle for you. Okay, not really a riddle. We're bad at riddles, but more like clues about our favorite molecule. It's polar, it's shaped like an outstretched V, its properties are awesome, and it makes up 3/4 of the surface of the Earth. That one always gives it away. Our favorite molecule is water, and we're not going to lecture you about how important water is and the fact that all life as we know it could not survive without it, because, yeah, that's true. But we really want to talk about what makes water so unique for biology itself. What are some awesome properties of water? Now, we mentioned the shape of water and the fact that water is polar. It has one very electronegative oxygen that is always trying to keep the electrons closer to it than to the hydrogens it's bonded to. And this actually gives oxygen a slightly negative charge because of the electrons that are spending more time next to it, and it gives the hydrogens a slightly positive charge. Well, that means that other water molecules have an easy time bonding together. Why? Well, because the hydrogen of one water molecule with its slightly positive charge can bond to another water molecule's oxygen with that slightly negative charge. These bonds among the water molecules are hydrogen bonds, And these are the very bonds that allow water to have many of the properties that we're about to talk about. Have you ever looked at a really tall tree and wondered, how does the water get all the way up there? I mean, it's got to go against gravity. Gravity. Well, in our plant video, we talk about the xylem. It's vessels within certain types of plants, like trees, and these vessels transport water. But what's really neat about water is that it sticks to the xylem walls in what is known as adhesion, and this helps fight gravity. But water molecules, with their hydrogen bonding, they also bond to each other in something called cohesion. It's almost a beads on a string kind of fashion. Water molecules evaporate from a leaf, and then the next water molecule in line is pulled upwards, and so on. This cohesion is really a big deal. Cohesion is also a reason that water striders, one of our favorite insect types, can skate on water. Cohesion contributes to the surface tension of water. Water actually has quite a bit of surface tension compared to many other liquids. And it's not just water striders that can walk on water. There are a lot of insects, spiders, and even larger animals like reptiles and some birds that have the ability to walk on water. So, to the Google for that. Now, with water being polar, it's also a very powerful solvent for other molecules. And that means that water can dissolve many other molecules, especially polar molecules and ionic compounds. Now, why does that matter? Well, this is really important because many of the processes that occur in organisms use water as a solvent. In our body system video, we talk about the function of kidneys, and you definitely couldn't have kidneys doing their function without water. Also, a main component for body fluids is water. I'll never forget when I was little, my father built us a pond. We had some goldfish in there, and I loved this pond. Well, in West Texas, where we're from, it can freeze in the winter. And one morning, I went outside, terrified to find that the top of the pond had frozen. And I thought our fish were goners. Only to find out that they were swimming and doing their fish activities under the ice layer. It's common for many substances to actually contract when they freeze and to become more dense. But water expands when it freezes and becomes less dense in its frozen state, resulting in floating ice, where it can actually make this insulated surface layer that makes a difference for many organisms underneath. And this is due to the hydrogen bonds. See, at freezing level, the making and breaking of hydrogen bonds, which usually happens pretty often, it's not happening very much when frozen. And so the molecules, they're set into this lattice of hydrogen bonded molecules, just far enough apart that it's less dense in ice form than it is in water form. And that's going to be very important for all of that aquatic life. Speaking of temperature, water resists changing its temperature. It has what's called a high specific heat. Specific heat, it's a measurement of heat that's needed to be absorbed or lost for 1 gram of a substance to change its temperature by 1 degree Celsius. And that's why on the first day that school is out in the summer, it may be super hot outside, but the water could still be pretty cool. It's really good that water's like this for life. It's stabilizing for aquatic environment temperatures. And it also means that water can absorb a lot of heat in the summer without reaching as high of a temperature itself, which is useful when winter comes along, because then the water can release heat as it cools in the winter. This also impacts the environment. Now, still on the topic of temperature, consider evaporation. Many animals rely on evaporation to cool them. Think of water molecules. They are moving, but those that have more heat energy, they are moving the fastest. And they're the more likely molecules to make the phase change to gas. And these molecules, as they leave, their energy, their heat, is no longer on your skin. And by the way, all of this is not just animals too. Plants use evaporative cooling to aid them in hot temperatures. Excessive high temperatures can be very dangerous for many different processes in both plants and animals. It can be damaging to the enzymes involved in those processes. So that evaporative cooling is very important. Well, we went through a lot of features of water. Definitely something to consider next time you encounter it, which, based on how much we depend on water, will likely be soon. Well, that's it for the Nina Sisters, and we remind you to stay curious.
Alrighty. So that is our first video. Please make sure that you're not forgetting your Notice and Wonder sheet. And here goes our next one. This is a review on some weather.
Predicting weather. Weather can change daily, but predictions about these changes can be made based on measurable factors like temperature and wind direction. Meteorologists are able to predict weather based on recorded measurements. Weather predictions based on these measurements are called forecasts. Weather is the condition of the atmosphere that includes temperature, precipitation, wind speed, and cloud coverage. Forecasts can be displayed on weather maps containing special weather symbols. The main components of forecasts include all of the components of weather, but also include information about fronts and wind direction. Weather maps are used to summarize weather conditions. Meteorologists around the world use similar symbols to represent the same things, which allows them to communicate with one another more clearly. This also creates a consistent system that allows anyone looking at a weather map to understand what is shown. Weather is determined by large bodies of air called air masses. Air masses can cover large areas of land, and most weather occurs at their edges, or fronts. There are three basic types of fronts used in weather forecasts. A cold front is the leading edge of a cold air mass that is pushing against the warm air mass. It typically brings gusty winds, drops in temperature, and heavy rains. A warm front occurs when the leading edge of a warm air mass is pushing in to replace a cold air mass. It typically brings gentle rains, warm temperature, and milder weather. A stationary front is the boundary between two air masses where no air is moving. It typically brings cloudy and wet weather, and it usually lasts for several days. This blue symbol is used to represent a cold front. This red symbol represents a warm front, and the blue and red symbol represents a stationary front. Variations in pressure caused by whirling masses of air also contribute to weather. A high pressure system, represented by an H, is a whirling mass of cool, dry air. It's usually associated with clear skies and weather. Winds spiral clockwise out from the center of a high pressure system. A low pressure system is made of a whirling mass of warm, moist air, and is represented by an L. It's typically associated with overcast and wet weather. The winds spiral counterclockwise toward the center of a low pressure system. Symbols that represent specific types of weather are also used on weather maps. This symbol is used to represent rain, which is precipitation that falls as water. This is the symbol for thunderstorms, which are storms with lightning and thunder. Ice storms are represented by this symbol. They are caused by freezing rain. Ice storms occur when a warm layer of air is trapped between two cold layers of air. Freezing rain falls and then melts, and then freezes again when it hits the second cold layer. This represents flurries, which is a light snowfall that does not stick to the ground and usually can't be measured. For heavier snow that can be measured and sticks, this symbol is used. Snow is precipitation. This symbol is used. Snow is precipitation that falls as ice crystals. Snow is made by water vapor that freezes that does not first become water. So by studying fronts and pressure systems, meteorologists can create general predictions about weather. These forecasts can be represented on weather maps using symbols like the one shown here.
All right, so that was our weather map review. And now we have a severe weather review, and then that will be all for our review today.
Hi guys, welcome back. Today we're going to talk about, Today we're going to talk about, are you finished, Thunder? Thank you. Thunder is pretty excited because today's episode is all about it. Well, to be more specific, today's episode is all about severe weather. But before things get all snowy, windy, and rainy in here, let's bundle up and ask ourselves the big question. What exactly is severe weather, and how is it different from regular weather? We know that weather is a condition of the air or atmosphere on our planet. Severe weather is the same thing, only more extreme. Extreme! But what does that mean? How do you know when weather is severe or extreme, and when it isn't. Well, severe weather is any dangerous act of nature that puts people, animals, or buildings at risk. Some light rain probably wouldn't count as severe weather, but a thunderstorm with heavy rain and lightning would. Tornadoes, blizzards, hurricanes, floods, and droughts are other forms of severe weather that can be dangerous to humans. But the more you know about these weather events, the less scary they seem. Let's start with tornadoes. A tornado is a fast-spinning column of air that stretches all the way from a thunderstorm cloud down to the Earth's surface. With wind speeds of up to over 300 kilometers an hour, tornadoes have the power to pick up and destroy everything in their path. While not quite as windy as a tornado, blizzards are storms with blowing or falling snow, high winds of their own, and cold temperatures. Hurricanes, or typhoons, are storms with high winds and heavy rain that start over warm ocean waters and bring lots of water with them. Speaking of lots of water, let's talk flooding. Floods happen when too much rain forces streams, rivers, and lakes to overflow, sending lots and lots of water where it doesn't belong, like your backyard. A drought is sort of the opposite. Think a lot less water, or no water at all. Droughts happen when an area doesn't receive enough rainfall, drying up rivers and lakes, killing trees, and ruining crops. All of those forms of severe weather have a big impact on the biosphere and the geosphere. How so? Let's find out. I'll conjure up some different types of severe weather to see exactly how shakeups in the atmosphere can impact the biosphere and the geosphere. Severe weather can be dangerous for people, obviously, but beyond affecting humans in the biosphere, severe weather can also affect plants and animals, too. Take a drought. After very long spells without enough rain, this nice mountain pond will become smaller, and maybe even dry up entirely. That means less habitat for the animals that live in the water, like ducks and beavers. But it also means less plant life around, because plants need water too. And fewer plants mean less food for animals like deer and elk that feast on them. But what about the opposite problem? What about too much water in the form of heavy rain? Really strong thunderstorms can sometimes bring lightning and high winds that can damage trees, maybe breaking off some of their limbs, uprooting them, or even setting them on fire. This is bad news, not only for the tree, but also for everything that lives in it. And finally, even the ground, as solid as it might seem, can be reshaped by severe weather. Strong, recurring floodwaters act like powerful rivers and can actually wear down rocky formations like mountains over time. And sometimes big flows of rainwater can cause a slope or hillside to collapse in an event called a mudslide. The atmosphere interacts strongly with the other spheres of the environment, particularly when it's cooking up severe weather. It can even move things in the biosphere and reshape the geosphere. So now you know how to tell if weather is severe or not. Ask yourself, does it put life or property at risk? Does it have a major impact on the biosphere and the geosphere? If the answer is yes, you're not dealing with normal weather patterns. Severe weather might be less common, but it has a much bigger impact on the world around you. Anything to add, Thunder? I guess that means we're done.
Alrighty, so now for our labs that we can do today. So the first lab choice that we have is for properties of water. All you need, let me make this a little bit bigger. All you need is a bowl, pepper, water, and some soap, okay? So you're gonna fill up the bowl about 3/4 up with water. You're gonna sprinkle the pepper on the top, right, until it covers the complete top. Please don't like mix it, just if you shake it on the top, it'll just stay on the top. You're gonna put a small amount of soap on your finger, and you're gonna put the tip of your finger in the bowl and observe what happens, all right? If you want to make a barometer, you're gonna need a small coffee can, plastic wrap, scissors, a straw, an index card, and a rubber band. So what you're gonna do is you're going to cover the top of the coffee can with a plastic wrap using the rubber band to hold the plastic wrap in place. The cover should be really tight, so make sure that it's airtight, all right? All right, so place the straw horizontally on top of the air top part that we just made, all right? So that 2/3 of it is on the can, and then you're gonna tape that straw down so that it won't fall off, all right? I'm gonna tape an index card to the can behind the straw, and the straw is gonna act as a pointer. You can also use a pencil too if you don't have that, if you don't have a straw. All right, so then you're gonna carefully record the location of the straw on the index card, all right? And then after 15 minutes, you're gonna record where the straw is at that time. You're gonna repeat, all right? Then for severe weather, you're going to make a baking soda volcano. You're going to need 6 cups of flour, 2 cups of salt, 4 tablespoons of cooking oil, warm water, plastic soda bottle, dishwashing detergent, food coloring, vinegar, a baking dish or like a cookie pan, and 2 tablespoons of baking soda. All right. So what you're going to do is you're going to make the cone by mixing the 6 cups of flour, the 2 cups of salt, the 4 tablespoons of cooking oil, and the 2 cups of water. Then you're going to stand the soda bottle in the baking pan, and you're going to mold the dough around to form a volcano shape. All right, make sure you don't cover the hole though. You're going to fill the bottle most of the way up with warm water and a bit of red food coloring. You're going to add 6 drops of detergent to the contents of the bottle. You're going to add 2 tablespoons of baking soda to the liquid in the bottle and slowly pour the vinegar in the bottle, and then you get to watch the reaction. All right, so those are the 3 different at-home labs that we have for you to do today. And until next time, this has been Science with Captain Corey.